Hi everyone, today I'm going to talk about average velocity, distance and displacement. Distance is the total measurement of how far an object has traveled. Displacement is a straight line from the start to the end point. For example, so let's say that a hiker was walking across a trail that was like this and it looped around a hill. Okay? So this is point A. This is point B. And so what would and so the distance would so I'm gonna change colors. So the distance would be this blue line that follows the red path because that's the total amount that the hiker has walked. Meanwhile, the displacement would be a straight line from point A to point B. Just a straight line. Scalar versus vector. Scalar measurements only have a quantity and unit of measure, such as distance, speed, temperature, mass, and energy. Vector measurements have a quantity, unit of measure, and a direction, like left and right, such as displacement, velocity, acceleration, force, and weight. Velocity. Velocity is the speed of an object and the direction it is moving in. Velocity is a vector, meaning it has a quantity, a unit of measure, and a direction, as before mentioned. Average velocity averages the different speeds and directions over time to determine an object's average velocity. Average velocity depends on the displacement and the total time. So here's the formula down here. Here, let me just get the pen out. So here's the formula right here. The V, as you can see, is the average velocity. The bar signifies average. Average velocity is measured in meters per second. X with a subscript of F is the final location of an object. X is like a mark on a pirate treasure's map. The subscript is below the X. F is description, meaning final. So that's kind of like where you end, and then XI is where you start, which is the initial location of an object. And I represents initial. And then the omega t, the delta t, represents time or change in time. T is the distance it takes from an object to get from xi to xf. An example problem is what is an average velocity for a cart that is moving along a straight pathway. The pathway is measured and marked along the entire 100 meters. The cart is at the 3-meter mark when the stopwatch is started, and the 22-meter mark when the stopwatch is stopped. The stopwatch says 28.4 seconds has passed. What is the average velocity? So what we're trying to find is the average velocity. So let me just circle that. Okay. So okay. So the pathway measured and marked along the entire 100 meters. We don't need that part. But what we do need is that it's at the 3-meter mark when a stopwatch is started. And then it's at the 22-meter mark when the stopwatch is stopped. So I'm going to highlight that since that's important information. And then the stopwatch has 28.4 seconds has passed. So I'll use the guess method to solve this problem. So the given is xi, which is 3 meters, xf, which is 22 meters, because xi is where it started. And so you see 3 meter when stopwatch is started. And then 22 is xf when xf, that's the final location. So you see 22 and stopped. And the time is 28.4 seconds. And it says 28.4 seconds. That's a dead giveaway. It's time. And the unknown is average velocity, since it says up here that I boxed average velocity. And so here's the formula, and then that's the equation that we're going to use for this step. And all we have to do in this step is replace xf with 22, xi with 3, and then delta t with 28.4 seconds. That's literally all you're doing there. And then the solution would be 0.669 meters per second, because the answer is 0.669 meters per second, because 22 meters minus 3 meters is 19 meters, and 19 meters divided by 28.4 seconds is 0.669 meters per second. I hope you liked this video. Bye. Please like and subscribe.